Quasars are some of the most extraordinary and powerful entities in the universe, radiating with an intensity that outshines entire galaxies. They're not just bright but are also the epitome of cosmic energy and hunger, devouring vast amounts of matter while emitting more energy than hundreds of billions of stars combined. Found in the darkest and most distant corners of the universe, these objects seem to possess an insatiable appetite for destruction. But what exactly are quasars? Where do they come from, how do they operate, and most importantly, could they pose any danger to us here on Earth? To understand quasars, you must first grasp the nature of the cosmic behemoths at their center, supermassive black holes. These colossal black holes, often millions or billions of times more massive than our Sun, are located at the heart of nearly every large galaxy, including our own Milky Way. Imagine an entity so powerful it can warp space, slow down time, and swallow entire stars whole. Our galaxy's own black hole, Sagittarius A*, may sound like the name of a quaint coffee shop, but in reality, it is a terrifying celestial body. Weighing approximately 4 million times more than the Sun, Sagittarius A is the supermassive black hole at the center of the Milky Way. In May 2022, humanity managed to capture its first direct image, giving us a glimpse of the monster at the heart of our galaxy. Despite its size, Sagittarius A* doesn't pose an immediate threat to our existence. It's not powerful enough to consume the entire Milky Way. In fact, compared to some of the universe's other black holes, Sagittarius A* is relatively modest. Instead of gobbling up galaxies, it acts more like a cosmic vacuum cleaner, sucking up gas and stars that stray too close to its event horizon. Yet, scattered throughout the cosmos are black holes that make ours look minuscule. These supermassive black holes can weigh billions of times more than our Sun, and they form the engines behind quasars, some of the brightest objects in the observable universe. Surrounding these supermassive black holes is an accretion disk, a spinning, glowing ring of gas, dust, and debris that gets heated to extreme temperatures as it spirals toward the black hole. As this material falls inward, it can reach temperatures of millions of degrees, releasing vast amounts of energy in the form of radiation. This intense radiation is what we observe as a quasar. The more material the black hole consumes, the brighter and more energetic the quasar becomes. In some instances, a single quasar can emit more energy than entire galaxies, illuminating the universe from billions of light years away. The discovery of quasars was a serendipitous event in the late 1950s. Astronomers scanning the sky for radio signals stumbled upon a series of strange emissions that seemed to have no visible source. By 1960, hundreds of these mysterious objects had been identified, though their true nature remained a mystery. These objects were initially termed quasi-stellar radio sources, or quasars, because they appeared star-like yet emitted enormous amounts of energy. Early theories ranged from quasars being new types of stars to more fantastical ideas, such as them being made of antimatter or the endpoints of wormholes. However, the real breakthrough came with the work of astronomer Martin Schmidt, who provided evidence that quasars were not stars at all but incredibly distant and powerful objects fueled by supermassive black holes. Despite skepticism from the scientific community, Schmidt's work eventually prevailed, leading to a new understanding of these cosmic phenomena. What makes quasars so intriguing is not just their brightness but their sheer strangeness. These objects, despite being so distant, emit jets of particles that travel at velocities approaching the speed of light. These particles move so quickly that they warp the very fabric of space and time, creating phenomena that seem to defy the laws of physics. At the same time, quasars help us confirm those very laws. One of the key pieces of evidence supporting the expanding universe theory comes from observing quasars. Many of these objects are speeding away from us at extraordinary rates, some at up to 90% of the speed of light. Their rapid motion provides concrete evidence that the universe is expanding, validating theories that have shaped modern cosmology. Even more fascinating is the age of these cosmic monsters. Some quasars date back billions of years, originating in a time when galaxies were first beginning to form. In fact, quasars are some of the oldest and most distant objects we can observe. This means that when we look at quasars, we are actually seeing light emitted billions of years ago, offering us a glimpse into the universe's distant past. Studying these objects is akin to looking through a cosmic time machine, revealing secrets about the early days of galaxy formation and the birth of stars. But quasars are not merely passive relics of the past, they are active participants in shaping the universe. Galaxies are like enormous cities, with stars, planets, and solar systems serving as their inhabitants. Just as cities evolve over time, galaxies also change and develop. Quasars play a critical role in this evolution. Their immense gravitational forces, combined with the energy they emit, can trigger star formation, influence the distribution of matter, and even shape the overall structure of galaxies. In some cases, quasars are born during the merging of galaxies, a process that can take millions of years but results in dramatic cosmic events. When two galaxies collide, their gas and dust interact, creating shockwaves that lead to the formation of new stars and, sometimes, supermassive black holes. Quasars, often born from these interactions, allow astronomers to study how galaxies evolve over time. One of the more visually spectacular phenomena associated with quasars is gravitational lensing. This occurs when the gravitational field of a massive object, such as a quasar, bends the light from a more distant object behind it. The effect is similar to looking through a magnifying glass, distorting and magnifying the light in fascinating ways. The resulting images often appear twisted and warped, like reflections in a funhouse mirror. Beyond its aesthetic appeal, gravitational lensing provides valuable data for astronomers, allowing them to study dark matter and map the distribution of mass in the universe. Quasars also serve a more practical purpose in the realm of cosmic cartography. Because of their extreme brightness and distance, quasars act as cosmic lighthouses, helping astronomers measure vast distances and map the universe. By analyzing the light from different quasars, scientists can determine how far away they are and create a three-dimensional map of the cosmos. This mapping technique offers a comprehensive view of the universe on a scale that was previously unimaginable, helping us understand the vast structure of space. One of the most exciting discoveries involving quasars occurred in 2007 when astronomers identified the first true binary quasar, a pair of quasars orbiting each other. This discovery was particularly remarkable because, for years, the radio source they observed was thought to be a single object. The binary quasar, located an astounding 12 billion light-years from Earth, is estimated to have a combined mass of around 100 billion suns. This discovery not only added a new layer of complexity to our understanding of quasars but also provided further evidence of the dynamic and unpredictable nature of the universe. In summary, quasars are some of the most mysterious and powerful objects in the universe. While they may seem like distant, galaxy-eating monsters, they play a crucial role in shaping the universe and helping us understand its vast, complex structure. From confirming the expansion of the universe to helping map the cosmos, quasars have proven to be invaluable to scientists. And with every new discovery, these enigmatic objects bring us one step closer to unlocking the mysteries of the universe. That wraps up today's exploration of quasars. If this journey through the cosmos sparked your curiosity, don't forget to like the video, share it with your friends, and stick around for more fascinating content on Waves Discovery.